Again to our physics lesson. Today morning we are doing physics 2, and I would like to continue emphasizing that we shall definitely keep alternating with mathematics 2. Before we go into the basics of the lesson from where we stopped last time, I want to continue to inspire and appreciate my colleagues, the teachers, and all of you, the students and the parents out there, for the work that you are doing and for keeping the SOPs as required by the ministry. I promised I will be sharing at least 2 inspirations, and my dedication still goes to the teachers. That a good teacher is like a candle. All of you may be aware that a candle consumes itself to give light, for others. A good teacher is just like a candle, and we are saying that the candle consumes itself to light the way for others, and so is a good teacher. I want to thank the teachers out there. I will also say that a truly wonderful teacher is hard to find and impossible to forget. I'll be sharing only 3. In the last one is that the influence of a teacher, a great teacher, to that fact can never be erased. There is one writer, one time I was moving and someone was putting on a t-shirt that was saying that a good teacher is never forgotten. For all the good teachers out there, kudos to you. To the students, I want to continue encouraging you to listen to what the teachers guide you with, and continue listening to your parents. Continue assisting them. Don't get tired. God is in charge. To the lesson, the last time I appeared here teaching physics, we were looking at prisms, and we had gone into application questions. We shall proceed today to look at one of the last bits. We are going to look at what we call grazing incidence and grazing emergency. Derive a few expressions and try out a few numbers as per the given time of our lesson. Teacher Kakuri is still in the house. I want to continue to remind you to continue following my work on YouTube and on Let's Learn from Home. For those students that have contacted me, I am sure you are getting a very good value out of me. And I want to encourage you that at least every week I upload at least 1 video, which should be able to add on what you already have. To the lesson, I want to encourage you to enjoy the lesson. Yeah, we are using a concept that we already covered. So I will be using a prism. I'll be considering 2 prisms, but one at a time. I'll be considering 2 prisms, but one at a time. We are going to consider a ray incident at the grazing surface. This ray will be refracted and will emerge out. Will emerge out. We are saying grazing incidence and emergency. So here it will emerge out. This is grazing incidence. The ray enters at 90 degrees and emerges out at an angle that may be now the refracting angle is A. If we extrapolate this to intersect, we still have that principle that would be the same as the refracting angle of the prism. Now we shall let this angle be theta. Let that ray emerge out at an angle theta. The angle of incidence is 90. And from our knowledge of total internal refraction, the angle when a ray is incident at 90 degrees, the angle of refraction automatically becomes the critical angle. If we let this angle be R, because if we consider what we call reversibility of light, this becomes I and this becomes angle of refraction. It implies that there is a fact here that I can talk about, that the sum of two interior angles is equal to an exterior angle will give us R plus C being equal to A. Now with that diagram, if I label this as P, this as Q, and this as R, I will go ahead to say that if we are interested in getting the deviation, if you are interested in getting the deviation total, we will extrapolate the emerging ray such that we have the deviation here and the deviation here, which is D2, and this will be the total deviation. That our total deviation D will be equal to D1 plus D2. Now, if we are interested in finding the maximum deviation, we can say that for maximum deviation to occur, for such a prism, for maximum deviation to come, the angle of incidence, the angle I, which we all know by now is the angle of incidence, should be 90 degrees. That is on side PQ of our prism. The angle of incidence on side PQ, which is this, should be 90 degrees for maximum deviation. And therefore, I can say that if I call this point A, I can say and call this point B, that at A, at point A, my deviation D1, 90 is actually equivalent to D1 plus C, implying the deviation D1 is 90 minus C. And at point B, on my diagram, because we are using the arrangement that this kind of arrangement in angle geometry, if this is 90, it is equal to the whole of D1 plus C. These are vertically opposite angles. Similarly here, at point B, we can say that theta, this angle is vertically opposite or directly opposite to D2 plus R, implying that our D2 there is also theta minus R. So the deviation which we call maximum, the maximum deviation which I have called D, I can call it D max, will be D1 plus D2 for grazing incidence. We have the D1, we have the D2. So my D max will give us an expression which will be 90 minus C plus theta minus r. If I rearrange this, it will give me my D max as 90 plus theta minus into r plus c. But remember, r and c are adding up to give the refracting angle. So I will say, but r plus c is equal to a, implying that I can say that my D max is actually 90 plus theta minus a. 90 plus theta minus a will be the expression for maximum deviation. We shall proceed to look at refraction on face PQ. Actually, at the point I have called A, I can say at A. If we consider refraction at A and use n sin I is a constant, assuming that the refractive index of the prism is n. If we consider n to be the refractive index of the prism, for n as the refractive index, the ref index of the prism, then n sin I, the light is coming from air, I will have n air, the sine of I, which is 90 degrees, should be equal to n for the prism times the sine of r, which is c. Not r is equal to c, and I is 90 degrees. Since the sine of 90 is 1, n is 1, sine of 90 is 1, I am not taking anything for granted here. That's why I'm showing this, because this is a very serious lesson. I will say it implies that 1 is actually equal to n, the sine of c. We have proved this before, but I must show it even in this lesson because it is important. What do I want to get? If I want to get sine c, it is 1 over n. If I want to get n, it is 1 over sine c. I will leave this here and say that n times sine c is equal to 1, and I'll call it my equation I. I'll call it my equation I. That is refraction at point A. If we consider refraction on face QR at point B, considering refraction on face QR, that is at point B, we already know the refractive index of glass is n, so I will use my n, the sine of the refractive, the angle of incidence is r here, the sine of r should be equal to NA, the sine of theta, because the ray gets out in air and it is incident here from glass. Even if we consider the reversibility of light, we would consider this as I and this as R, and we would still get the same, because it would be NA, the sine of theta, being equal to n of the prism times the sine of R, which would still give us the same. But we already know that NA is 1, and therefore we will proceed in our next narration. We also know for a fact that R can be expressed in terms of the critical angle and the refracting angle of glass. So we can say, but R plus C is equal to A, implying that actually r is a minus c. So I can say that my n, the sine of r is now a minus c, will be equal to the sine of theta. Will be equal to the sine of theta. My n times the sine into a minus c is sine theta. My intention, or our intention, is to find refractive index of glass, the expression for refractive index, and hence find the expression for the sine of the angle theta. So, if we open brackets, if we expand this expression, expanding the expression on the left-hand side will give us, I know expanding the space is limited, but I will try to make sure we expand. N becomes common, and I'll put major brackets. Sine will be sine of A times the cosine of C minus cosine of A times the sine of C will be equal to the sine of theta. When we open brackets, we are going to obtain an expression that has n sine c, and we know n sine c is 1. What is our intention? Our intention is to find the expression for sine theta, which we already have. So I will say that sine theta is actually equal to n, the sine of A, the cos of C, minus n, the sine of C, and the cos of A. But here we can say from equation 1, n sine C is 1. So we can replace this with 1 and say that sine theta will be n, the sine of A, the cos of C, minus the cos of A. Minus the cos of A. I have substituted for n sine C using equation 1. And after getting that expression there, I am going to call that equation 2. I am going to call that equation 2 here. If I label this as the second equation, I want to find the value of sine theta, and that means I want to eliminate angle C. I will say, since from this equation I can get my sine C, since from 1 sine C made the subject is 1 out of n, it implies that, and we know the first identity, that cos squared C plus sine squared C is equal to 1 from mathematics. It implies that the cos squared of C is 1, is therefore 1 minus the sine squared of C. And I have the sine of C. When I square it, I know what I can get. So the cos squared of C will actually be 1 minus 1 over n squared, implying that the cos of C will actually be equal to n 1 over n. Let me write it like this. If I take the LCM, I'll have n squared minus 1 over n squared. So it will be 1 over n into 1 into n squared minus 1, and this is in a square root. I'm emphasizing that if we take the square root to find the cos C, we will be able to get that the cosine of C will be equal to 1 over n, because we have taken the square root of the n squared, which is the denominator, to get 1 over n. But the rest stays in a root form. We are still proceeding, and I don't want my followers to get stuck. I will be substituting for this cos C here shortly to find the final expression. I am going to substitute for cosine C using that, and I find the expression for the sine of theta. And I'll find the expression for the sine of theta and consequently find the value of theta. We are using grazing incidence. The pause that you notice and the exposure of all the work is to allow you be able to either take a picture or harmonize what you are actually seeing before I clear off the first part of our blackboard. Before I clear off the first part of our blackboard, we can capture that. I am going to clear off, and then after clearing off, we'll proceed to give you the final expression upon substitution of cos of C. Remember, we are trying to derive an expression for the value of the angle theta, which is the angle of emergency, and later the value of refractive index. Later, the value of refractive index, as you shall note. So substituting for cosine C in equation 2 will give me that my sine theta is going to be equal to n, the sine of A, times my cosine of C is 1 over n into the square root of n squared minus 1. I'll put the power half, which is the square root, and then I take away the cosine of A. Definitely this n will cancel, and I can say the sine theta is equal to, I can write this first, n squared minus 1, the power half, times the sine of A minus the cos of A. At this stage, we have sine theta, and therefore it implies if we are interested in the angle theta, it will be the sine inverse of what we have here. The reason why I use the rectangle is to emphasize that that is the landmark for those that are following this lesson. It is to emphasize to you that that is the expression for the sine of theta. If we are required to find the value of the refractive index, which is n, to find n, I'll call it the expression for n, for refractive index n. To find the expression for the refractive index n, we will pick our expression again back from right here. We will consider it from right over here and say that n squared from n squared minus 1, the power half, the sine of A. If we made this the subject, it would be the same as the sine of theta plus the cosine of A. Since our intention is to make n the subject, I will divide by sine A both sides. Divide by sine A throughout. If we divide by sign A throughout, what do we obtain? I will clear both the space and the next space. And I want to encourage students that are following this lesson. Yes, what I am going to share should not work right now because both of us are in two different places. But in the normal school program, I want to advise that when the teacher is teaching, the student is expected to listen. When the teacher is writing and the student is writing at the same time, one of the two, and definitely the student, will lose out. When the teacher is writing, always make sure you are attentively listening and watching what is going on. A good teacher will always give time for the students to write when they are finished emphasizing the point. But for this kind of setting, you can follow. And that is why I always give you an arrangement or some time for you to capture. Because when you compete with me when I'm writing and you're writing, it means you may not actually all learn. So when we proceed, we are dividing, and I'll divide straight away. When I divide by the sign of A, my left-hand side becomes n squared minus 1 to the power half. The sign A here will disappear because I've already put a statement, and it will be appearing this side. It will be appearing this side, here where I divide. Alternatively, I can indicate it there so that those who may not understand that can know how it disappears. I appreciate as a teacher that we have different categories of students. And that is why I'm trying to make sure I do almost everything systematically to be inclusive to all categories. Now, when you do this, it means you have to repeat that step. I have to repeat that step to show the outcome, that this one has disappeared. Since our interest is to find n, and we have a fractional power, we must square in order to remove that power. I will simply put a statement this time, squaring both sides. If we square both sides, from your knowledge of indices, when we square this half will disappear. In primary, my colleagues normally tell you that if you have root A squared, this disappears with the square root. But the explanation is that root A is the same as A to the power half. And when we square it, we actually write it as A to the power half times a half. There could be A-level students who have never known why. They always tell you that that is that. It is the same as root A times root A. Again, this is SADS, but it is also indices. They would always say it is equal to this. But the rationale or the explanation is that you are saying it is that. And therefore, when you use indices, you are adding the powers. And a half plus a half is 1. This is for purposes of explanation. I will definitely rub it off. And for A-level students, I would have assumed it is obvious. But from the experience I have, there is nothing obvious with science. So squaring both sides, I will now write this as n squared minus 1. Someone who will find this work on Facebook, on YouTube, on the BBS Facebook or YouTube, or my Facebook account, or my YouTube account, will not know why is this like that. But when they see the word squaring, they should know that the squaring was done without showing that, but I have emphasized that, which has been captured. When we square this side instead, we shall have sine theta, I will just leave it like this, plus cos of theta, cos of A, sorry, over the sine of A. I will square it at a go like this. Since our interest is finding n, our n squared therefore will be, we add 1 both sides, will be 1 plus the sine of theta plus the cosine of A over the sine of A. This is squared. And finally, we take the square root. So taking the square root, again on both sides. What we do on the left, we do it on the right. We will get our n finally as, I will just use the root format, as 1 plus the sine of theta plus the cos of A over the sine of A. This inside the bracket is squared, and this will give us the expression. It could go further than this, but I will choose to leave it there. It could go further than this because you can open this. This bracket means even the denominator is squared. The whole thing is squared. But you can open it up and simplify it to a different expression in your later working. So we have been able to get the expression that can allow us to find the emergent angle if we know the refractive index and we know the refracting angle. And we can also determine the refractive index of the prism if we know the emergent angle and the refracting angle of the prism. That is the first case. And now, for the next case, which I'll call B, that is grazing emergency. We shall just summarize this one, since we have already captured grazing incidence and grazing emergency. If we have the reverse of what I have done in the first diagram, that we will handle inclusive of what we have just discussed. We can have a scenario where instead of the grazing emergency, we reverse the first diagram. That light is incident at an angle and grazes. Or we say light is incident, grazing, and emerges. That is still case A, which we have looked at. But this case is unique in the sense that we are considering a ray incident at grazing, refracted, and it simply grazes again on the other face. It simply grazes again on the other face. This is what we want to look at. If this is the case, it means that the angle of incidence and the angle of emergence are the same. And therefore, these supposedly angles of refraction all become critical angles. They all become critical angles from our, definitely our previous lessons. And we have seen here one thing that for the critical angles, this triangle here, the sum of two interior angles is equal to the refracting angle of the prism. I want to emphasize that I have not put this statement here in words, but I have said that if n is known and A is known, using this, theta can be calculated. And if theta is known and A is known, using this, n can be calculated. Candidates should take note of that. For part 2, I simply want to say that if the refracting angle of the prism A is steadily increased, if it is steadily increased, a point will be reached. A point is reached when light grazes on incidence and grazes on emergency. And when that point is reached, we can obtain the expression. When grazing incidence and emergency are obtained. And when this is done, it implies that my C plus C is actually equal to the angle of the refracting angle of the prism, implying that A is actually equal to 2C. And if at all we are interested in finding the deviation will be equivalent to the critical angle. The total deviation, as you can see, here the deviation here is 90 minus C, and here the deviation is 90 minus C, and it implies that total deviation D, if I call it D, will be 90 minus C plus 90 minus C, which will become 180 minus 2C. But what is 2C? 2C is A. So we can say that the maximum deviation D is actually 180 minus A, since we already know that 2C is A. That is what we can emphasize on that part of the prism. That is what we can emphasize there. That is what we can emphasize there. We can try out an example. We can try out an example. Which I'll write down. Yes. There is the question. There is the question. I always encourage students to read through the question at least once after copying it. And if it is in a question paper where you're not going to copy it, you read through it at least twice before you solve. First time you're trying to understand the question, second time you're inherently interpreting it. You are inherently interpreting it. I will sketch this diagram over here as we begin our solution. They are telling us that this prism is immersed in a liquid. I am beginning to immerse it in a liquid. And the refractive index is 1.52 of the prism. The refractive index of the liquid is 1.25. A ray is incident at an angle in a liquid. If I take this as my normal, I'll put a ray here, and the angle of incidence is one of the things we want. I'll call it theta. It is refracted. I could let the angle of incidence come from this side, okay, no problem, and call it my theta. It is refracted, and according to the question, they're saying on the first face, it is just critically refracted on the second face. This means that it grazes. That's what that interpretation means. Meaning that this angle here is the critical angle, and if this is R, they are telling us this is 60 degrees. It implies that that is 90, and that sketch is very, very important, or that interpretation, such that this is 60 degrees. Now, it therefore implies that if our A is 60, our N liquid is 1.25, our N glass is 1.52. It implies that on the first face, on the use of that, I can say on the second face, if we consider refraction on the second face, we shall get that 1.5 to the sine of the critical angle should be equal to N of the liquid, which is 1.25, the sine of 90. At this point, N liquid sine of 90 should be equal to N prism sine of C. So we can get sine of C as 1.25 over 1.52 times 1. And C will be equal to the arc sine of that value. And when we use that, that value would be 0.8222 368 approximately. And this would give us the value of C as 50, if you check, 55.32 degrees. But C is not one of the values required, but we must start from there. After getting C, you will note as students that R plus C is equal to A. So our R is going to be equal to A minus C, which will be 60 minus 55.32. And therefore our R will be, which is also not directly required, but required for our calculations, will be around 4.68 degrees. After getting our R, we can now consider refraction on this face and look for theta. We can consider refraction on face 1. On first face, will give us 1.25. The sine of theta should be equal to 1.52, the sine of R. But we know R. So sine theta becomes 1.52 out of 1.25 times the sine of 4.68. And sine theta will therefore give a value which will ultimately give us the value of theta as sine of theta is equal to, this will give us the value of theta finally as 5. These are small angles, but that is what you should be able to get if you compute. Remember, I always emphasize that when you're using trigonometry, you must make sure that your calculator is in the degrees mode. And last but not least for this number, the deviation d is expected to be theta minus r on the first face plus 90 minus c. And therefore, deviation will be theta, which is 5.69 minus 4.68 plus 90 minus the c, which is 55.32. When you compute this, you should be able to get your deviation as 35.69. 35.69 degrees. As we wind up this lesson this morning, I want to give you some homework. I want to give you some homework. But before I wrap off, I will still, as usual, give you time to take a picture. We still have some reasonable time that could allow me write one number and ask you to solve it. I would ask you to take a picture so that I can erase one part and put for you a number or two that you can do in your free time. I can put for you a number or two for you to try out. Yes, I want to emphasize that you can take a picture of these numbers and try them out. When we meet next time, I'll simply give you the feedback of the answers you are expected to score or to obtain. When we meet next time, I'll give you the answers of the values asked for in these two numbers, or even go through them before we look at the others. There are some additional questions here at the bottom, and I want to emphasize that you can get additional work from the question bank. I want to encourage you to keep reading. Waste no time. Remember, it is always very, very important for you to keep reading. Very, very important for you to keep reading. I want to encourage you to continue reading. This is the exercise for today's lesson. I want to wish you the best and a nice weekend, and continue to encourage you to check and subscribe to Teacher Kakuru's YouTube channel. God bless you. Gachali Mabaga.
Si bombo kalule neye kabalagala tobana bweraliikirivu bwonna olw'omusingi okutambuzibwa ebyenjigiriza n'ensoma y'abayizi ey'omulembe mu masomero gaffe gano gonna tusomesa arts ne sciences okuviira ddala ku sini esooka okutuuka ku sini ey'omukaaga nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. ebibiina abaana mwe basomera eby'omulembe omuli buli kimu ekikwata ku ebyo bye basoma, ebisuula ebyazimbibwa obulungi, ebigazi ate nga biyonjo. Okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga. Wamune.
Combo University, a private chartered university that offers world-class education at all levels, including certificates, diplomas, bachelor's and master's degrees. Our courses include computing and IT, law, journalism, nursing, business administration, education, fashion and design, and many more. Admissions for the August 2020 intake are still open. Will you join us?